Alright YouTube, what's up? What's going on? Gonna do a quick little unboxing of this Turnigy 540 watt DC power supply I just got. Planning on running my two high-tech LiPo chargers on this guy. Should have enough power to do the job. 12 to 18 volt DC output, up to 30 amps. I won't be drawing anywhere near 30 amps off of this guy. This went on sale on Hobby King, little weekly sale, one of their deal items, and the price was right, so I just had to have it. Let's get to it, see what she looks like inside. Packaging is definitely less extravagant than the Turnigy graphene batteries I bought, but it's definitely suitable because it's a pretty good foam there, so I'm pretty sure there's nothing wrong with this guy. Got an instruction manual. I'll have to look that over real quick. We got power supply cord with a American style plug on it because we're in the States here. And here we have the power supply itself. Let's see here. What do we got? There we go. And here we have it. Nice little LCD display on there. Adjuster for the voltage. We got our read manual first. Gotta have warnings on it. Gotta cover their butt. Got our outputs on the other end. Hoping this makes it so I can charge my two 6S batteries at the same time on a charger and actually get 5 amps of charging out of it. So right now I can only get 4.2 to 4.3 amps with this guy plugged into the wall. So I'm hoping with the DC power supply I can get at least 4.2, 4.3 amps on both channels instead of only one channel. So we'll see how it all works out. Okay, we're back. We're gonna do a little operational test now. We got power supply turned up to, oh, it's on 18.1, huh? Let's make it down to actually, oh dang, that's really sensitive. Barely turning it at all, and it's jumping around. Very, very sensitive dial on the amperage adjust. Or the voltage adjust, I mean. My mistake. Very, very sensitive dial. I think it'd be a little bit better if it had a touchpad where you could go up incrementally. That'd make things a little bit better. Let's leave it at 17.9. Let's see here, we got this charger set up to do two 6S batteries at 5 amps. We're going to have this one running two 3S batteries at 5 amps. Should be able to do this successfully with this DC power supply. I just really want to check and see if this one does the 6S batteries, because before the DC power supply I can only charge one 6S battery at a time with this charger because there was not enough wattage. I had to put all the wattage to one channel to charge at 4.3 amps. So all things go well, I should be charging at, oh look at that, 4.3 amps on both channels. I really like that. So let's run this other charger here. See if this guy can handle all the amperage I'm about to pull out of it. Because we're at 17 volts right now. We're pulling 16 amps. Let's see if we can get all four of these up to... Oh wow, look at that. This one's actually charging at a solid 5 amps. It's not charging at 4.3. That is nice. I like that. There must be a lot less internal resistance in these 3S packs than there is in the 6S packs. That's the only reason I can see why these only charge at 4.2 to 4.3. Because the internal resistance of the battery is higher, so it can't put out the voltage because of the resistance. It loses a little bit. But yeah, this charger used to only run at 4.2, 4.3 with the 3S batteries also. But getting a full 5 amps with the DC power supply. And both chargers running at full throttle. We're only pulling 20 amps of our 30 amp max at 17.8 volts. I think we have a success here. Okay, so I've had these chargers running for a little while now. Got them all, my batteries bagged up and everything, you know, safety first again, you know, like we always like to say, safety first. So we've been running for 20 minutes now? Yeah, 20 minutes. Good solid 20 minutes. Both these guys running for 20 minutes, and I just want to see how warm they are. See what our heat temperature is looking at. Oh, yeah. Yeah, we like that. That's nice cold air coming out of the inside of the chargers. They feel cold to the touch still, nice and cool. So, not running those internal power supplies is definitely keeping the chargers a lot cooler. Wires here, power supply wires, they're not even thinking about getting warm. They're nice and cool. I made these banana XT60 leads up myself. I think they turned out pretty nice for homemade. And our power supply itself, wow, that's still really cool too. It doesn't even... If I put my hand on somebody's forehead that's got a fever, it's warmer than this. The bottom has a little bit of warmth in it, not much. By no means is it getting hot, that's for sure. So, good power supply, it's not overheating, getting hot, staying nice and cool. That must mean the cooling fans are doing its job. Oh, I guess we bumped up to 18.2. I must have moved my dial a little bit. There we go. Let's see here. Oh, turn the voltage down and the amperage draw goes up. I suppose that's a given. If you got more voltage coming, it's going to draw less amps. Less voltage coming, it's going to need to draw more amps to produce the same effect. It's a nice little curious thing to know there. You got the amperage turned up as high as you can have it, you'll draw less amps. But yeah, I really think I have a winning situation here. Everything's staying nice and cool. These battery chargers used to get fairly warm. I mean, they blew out warm air anyways, you know. They never got hot, but now they're staying ice cold. And like I said, that's definitely going to save on the internal circuitry when it doesn't get hot, because heat and electronics, that's how they fail. They get overheated and they fail. They stay cool, they last a long time. So If you watch the whole video, I appreciate it, and thanks for watching.